Hey everyone, and welcome back to the channel. We're diving into a super cool paper today.
Oh, I know this one.
You know it, huh?
Yeah, I was really excited to see this.
It's EVEv2 from the BAI Vision team,
Yeah, awesome team.
and it's all about making vision language models simpler.
It's a really interesting approach.
So no more separate encoders for images and text.
Exactly, they're going completely encoder-free.
Wow, with just one unified architecture.
It's way more streamlined.
And it works.
Yeah, and that's not all. They're actually getting some pretty impressive results with this.
Oh, really?
Yeah, it's even outperforming some of the more well-known VLMs out there.
What?
On a number of benchmarks, and get this, it's doing it with less data.
No way. EVEv2 is a single model that can handle both images and text.
Yep,
It's efficient, and it's beating models trained on way bigger datasets.
that's what they're showing.
Amazing. But I have to ask, how does this thing actually work?
Well, it's all thanks to this really cool thing they call the divide and conquer architecture.
Divide and conquer.
Yeah, imagine it like they design the model in a way that visual and textual information kind of get processed in their own lanes, but within the same like overall structure.
Okay, that makes sense.
So the visual side isn't slowed down by what the language model already knows.
Oh, I see. So they're separating the learning process.
Exactly. And that helps the model learn about visual information like from scratch.
Without any preconceived notions.
Exactly. And there's this other really cool thing. They got rid of those big pre-trained vision encoders.
The ones that other VLMs use?
Yeah, and they replace them with like a really simple patch embedding layer.
What does that do?
It basically takes an image, breaks it down into these smaller pieces, and turns them into numbers that the model can work with.
Interesting. So they said goodbye to the big pre-trained models.
And it seems to be working really well for them.
That's wild. Are there any other benefits to this approach?
Yeah, actually this also makes the model super flexible because it doesn't need those pre-trained encoders. It can handle images of any size or shape.
Oh, wow. So it doesn't matter what the image looks like?
Pretty much, yeah.
That's incredible. Again, so how do you train something like this?
Well, it's definitely not just showing it some images and text and hoping for the best.
I figured.
It's this whole carefully planned process, actually with 4 different stages.
4 stages.
Yeah, the first one is called LLM-guided pre-aligning. And basically what happens is they train that patch embedding layer I talked about with, image-text pairs, but they keep the language model's weights frozen.
What does that mean?
It means the language model isn't really learning anything new at this stage. It's more about giving the model a starting point, helping it link images and words together.
Okay, so it's like laying the foundation for the model to understand how visuals and language connect.
Yeah, exactly. And then comes the vision perception learning stage, where things get even more interesting.
What happens there?
This is where the model starts to really develop its ability to see. They train the vision layers with images that get increasingly more detailed.
How detailed are we talking?
All the way up to a resolution of 1600 by 1600 pixels.
Wow.
So it's kind of like the model's world is coming into focus.
That's an awesome way to put it. But we still need to make sure it can actually use the language part, right?
Oh, absolutely. And that's where a third stage comes in.
Which is?
Vision text fully aligning.
What do they do in that stage?
They fine-tune the whole model on a question-answering data set. So it's like forcing it to make those connections between what it's seeing and how it understands language.
Clever way to test it.
Right, like can it answer questions about the pictures it's looking at?
It all ties together.
Yeah. And last but not least, there's supervised fine-tuning.
So that's the final step.
It is, and in this step, they train EVEv2 on these high-quality instruction data sets to really refine its ability to follow instructions.
So we can understand what we're asking it to do.
Yep, and understand those like dialogue patterns.
So it's almost like a finishing school for the model.
I love that. It learns to interact in a more human-like way.
Okay, so we've got this streamlined architecture, a smart training process, and it's supposed to be really efficient. But does it actually work?
You're gonna love this. The results are pretty impressive. EVEv2 is holding its own and even doing better in some cases than other VLMs.
Really?
Yeah, both encoder-free and encoder-based ones.
Wow, that's impressive.
And across lots of different benchmarks too.
And remember, it's doing all of this with less training data.
Exactly.
So less data, better results. That's got to have people in AI pretty excited.
Oh yeah, definitely. It's turning a lot of heads.
Where does it really shine? Like what benchmarks?
Well, it's especially good at things like image captioning.
Oh, cool.
And visual question answering, even doing well with image retrieval, like when you search using text descriptions.
Those are tough tasks. They need to understand both images and text to get those right.
Exactly, and it shows EVEv2 can really handle that complex stuff.
This isn't just a small improvement either.
Nope.
EV2 is a real contender in the VLM world.
For sure.
What's the secret? How's it getting these results with less data?
It's a few things working together,
Okay.
but a big part of it is that minimalist patch embedding layer we talked about.
Right, the one instead of those big pre-trained models.
Yeah. By keeping it simpler, they made a model that's way more data efficient. It doesn't need to be fed mountains of data to learn about images.
So it's like they found a really elegant way to represent visual information without all the extra baggage.
Exactly.
It makes you wonder if we've been overthinking things with all those huge pre-trained models.
It definitely raises some interesting questions about how we design VLMs in the future.
It does. Speaking of the future, what's next for EVEv2 and encoder-free models in general? Are there exciting areas of research you're looking forward to?
Oh, absolutely. This feels like we're just getting started.
Where do you see the most potential?
Well, scaling up EVEv2 is an obvious next step.
You mean like training it on even bigger data sets?
Exactly. Even more diverse data. We already know it's good with using data efficiently, so imagine what it could do with even more to learn from.
More data, more power. That's how AI usually advances.
Right. But I'm also super excited about going beyond just vision and language.
You mean like adding other types of data?
Yeah, like audio, video, even sensory data.
Wow.
AI that has a much richer understanding of the world using all these different senses.
AI that can see, hear, feel, and understand. It's like something out of science fiction.
It is pretty mind-blowing.
What could we do with that kind of AI?
Think about robots that not only see their environment, but understand what we're saying to them in natural language.
That would change everything. We could really change how humans and computers work together.
Definitely. It feels like we're on the edge of some huge breakthroughs in AI.
But let's come back to reality for a minute. What are the key takeaways for people working on AI right now? What should they be focusing on?
I think EV2 shows us that simpler can be better sometimes.
Okay.
We don't always need those massive models to get amazing results. By focusing on efficiency, streamlined designs, and smart training, we can do amazing things with less computing power and less data.
It's a good reminder that innovation isn't always about making things more complex.
It's about finding the elegant solutions.
What about the data itself? Any takeaways there?
Oh, absolutely. The researchers actually used a modified caption engine called Dense Fusion ++Day to make really detailed captions for the training images.
Interesting.
That tells me investing in good data generation techniques can be super important, especially for models learning from scratch.
So garbage in, garbage out applies to AI too.
It really does. You have to be picky about what data you feed these systems.
It's not just about the algorithms, it's about the data quality as well.
Yeah, and when you combine those two, that's when the magic happens.
What else should our listeners keep in mind as they look into encoder-free VLMs?
Well, it's important to remember this is still a new area. There's so much more to discover. I think this research is going to inspire a ton of innovation in the years to come.
It feels like a new frontier in AI.
It does. And who knows, the next big breakthrough could come from someone listening right now. That's what's so cool about EVEv2. It shows that innovation can come from anywhere.
It feels like EVG is really shaking things up in the world of VLMs.
Yeah, it's a good reminder that sometimes you got to step back and rethink how we're doing things. The best solution isn't always the most complicated.
And speaking of rethinking things, the authors did mention some limitations of EV2, right? What were some of those?
Yeah, they're upfront about it. The current EVEv2 does have some limitations, mainly because of constraints with data and, just the computing power they had available.
So what kind of limitations are we talking about?
Well, for example, they did push the image resolution during training, but it's still not quite at the level of what humans can see.
So there's room to improve how much detail the model can handle.
Exactly. And they also pointed out that right now, EVEv2 might not be the best for tasks that need super specific visual understanding.
Like what?
Like if you needed to tell the difference between two really similar objects, it can handle general stuff really well.
But might need some tweaking for those super specialized jobs.
Right. And another area for improvement is how it handles language.
It can understand basic instructions, right?
Yeah, and descriptions. But things that need a lot of context, like metaphors or humor, it might struggle with those.
So it's fluent in vision, but still learning the nuances of human language.
Haha, that's a great way to put it. But the good news is, researchers are already looking at ways to improve that.
Oh, how so?
Some are trying to give these models access to external knowledge bases.
Like a giant library of information.
Exactly. And some are using techniques from natural language processing to help VLMs understand language better.
It sounds like the future of VLMs is going to be a really cool mix of computer vision, natural language processing, and even cognitive science.
Yeah, I think you're right. And that brings us back to one of the big takeaways from EVEv2.
Which is
That innovation in AI often comes from blending different fields.
combining the best of different worlds.
Exactly. That's how we'll make AI systems that are truly groundbreaking.
This deep dive into EV2 has been fascinating. We've covered so much.
It really has, from the technical stuff to the bigger picture of AI research.
And if you're itching to learn more, we've got links to the research paper and more in the show notes.
Definitely check those out. We want to hear what you think about EVEv2 and where you think VLMs are headed.
The world of AI is always changing. What's revolutionary today might be old news tomorrow.
That's true. So stay curious, keep learning, and who knows, maybe you'll be the one to make that next big discovery.
Until next time, everyone, keep exploring, keep innovating, and we'll see you in the next episode.